Hi, I'm Eric Hatcher. Welcome to Lucid Imagination's webinar, Developing Rapid Prototyping Search Applications with Solr. Why do you want to prototype? First, we want to prototype so that we can ensure that Solr can handle your needs of your application, of the data that you're putting in. You want to be able to mitigate the risk and learn the unknown. If you're new to Solr, you want to make sure that Solr can handle your type of data and can handle the type of scale that you're looking for. So you want to do a little bit of prototyping to make sure these types of things work for you. Also, we want to actually develop a user interface because, in my opinion, the user interface actually is the application that you're building. And what better way to convince decision makers that Solr is the right solution when you can show them an actual user interface that has your search capabilities that you need. And what we're going to do is we're going to build something that's going to be really quick, it's going to be easy, and it's actually fun to build something like this. Okay, so we're going to start with LucidWorks for Solr. LucidWorks for Solr is Lucid's distribution of Apache Solr 1.4, and it's got several things that are pre-configured in there that are above and beyond the distribution that you can get from Apache Solr. First of all, it's got Caret 2 clustering built in. We also have the search user interface deployed in there so that we have the velocity response writer. We're going to see a lot more about that in a moment. And we also have deployed a root context into the container, either Tomcat or Jetty. The LucidWorks distribution contains both of those so that you can choose which container that you'd like to use. This root context is very handy for serving static files. We'll see that when we add a JavaScript library into the user interface. Also, we include the KStem library, which is a slightly better stemmer for English that we're shipping with the LucidWorks distribution. Okay, so here's the requirement. This is the application that we're going to build during this presentation. Basically, your boss comes to you and says, I want my big enterprise content repository searchable. That content repository is going to have Word, PDF, PowerPoint, HTML documents, other types of rich documents in there. And probably it's going to be accessed through some proprietary API. It could be a SharePoint repository, Documentum, and what have you. So what we're going to do is we're actually going to start the application with the simplest possible thing that will work. Okay, so I really encourage you to, when you're prototyping, whittle down the problem so that the next step that you do is going to be the simplest thing that you can do that's going to put you towards the goal. And in this case, we're simply going to index a PDF file. We're going to ignore the fact that we need to talk to some kind of big content repository. We know we're going to be able to get that PDF from that content repository. We want to push that into Solr and make it searchable right away. Okay, so now we're down to some technical nitty-gritty here. What we're going to do is post that PDF file into Solr. Actually, we're going to stream that in this particular example using curl, which is an HTTP command line tool. We're going to hit the update extract handler. This update extract handler takes rich content either from a URL that it will go out and retrieve, or from a local file, and that's what we're doing in this case, or that content can actually be posted into Solr over HTTP. Okay, so we did the simplest thing that we could do here. We simply told the update extract handler that there was a file on our file system that's a PDF file. Now, we got an error message right off the bat. Okay, this error message said that it's missing a required field ID. Okay? And the reason that it told us that is because the schema that's built into the LucidWorks distribution, which is an example schema, has the ID field, and it's set to be required, and it is actually set to also be the unique key for Solr. Okay, so let's talk a little bit about this unique key, because this is one of the important things that you need to get right off the bat when you're working with Solr. Every application that I've come across with Solr requires a unique key for each document. It's not a requirement as far as Lucene or Solr is concerned that you have a unique key, but in the real world, pretty much every application will have a unique key. So the unique key is used to update a document. So if you send another document into Solr and it has the same ID as an existing document in Solr, it will be replaced. And by replace, that means it actually performs, in the Lucene terms, it actually deletes the original document and then re-adds the new document that you're sending in. And so this is a Solr benefit here, is to have this unique ID. What you do to create a unique key. Sometimes it's pretty obvious. If the only data source that you're going to be indexing is a database, a single table database, you could use the primary key from that database as the unique key in Solr. Or if you're crawling websites, the unique key could simply be the URL of the site of the page that you're crawling. However, when you're mixing and matching multiple data sources, it can be tricky to come up with a unique ID scheme. And one scheme that the simplest possible thing here that works is to come up with some code for each data source, a unique code for each one. For example, in this case, we're indexing products and articles. And they may both have the same unique key in their own repositories or databases, but we need to have some unique, unambiguous key that we're going to send to Solr. So we come up with an artificial key where we prefix it with a data source identifier and then the ID within that particular data source. Okay, now that we've talked a little bit about the unique key, let's go ahead and use the extract handler capability to set a literal field value. So in this particular case, we're going to be sending that same PDF document into Solr, and we're going to add another parameter to that request and say, literally, the ID value is, and we simply put the same file name that we're going to index here, just assuming that the file names are going to be, the file paths are going to be unique in this particular situation. And the response that we got back from that curl command is a successful response. That means that that document got into Solr successfully. And we simply, thanks to the user interface that's built into the LucidWorks distribution, we have basically an instant user interface. We simply go to Solr / this funky name here, ITOS. We're going to talk more about that, what that means on the next slide. But the user interface here is relatively generic, although the example schema that comes with Solr is built for the example documents that come with Solr. And so the facets that we see here, we're not seeing anything interesting over there. There's actually a cat field in the example documents, and we would see facets if we had indexed the example documents. But each of the results displayed here is the field name, a colon, and then the actual field value. So we have a generic view of the hits of our search. And by default right now, the search is *:*. It's basically matching all documents and showing you the first 10 of all of the documents that are indexed. In this case, of course, we only indexed a single document. All right, so how did that user interface get generated? It got generated using the velocity response writer. It's got a funky name based from the Latin word celeritas, and so we call it celeritas. The reason that it's called that is because celeritas means, in Latin, it's swiftness or speed, and it's the reason the speed of light is represented by the letter c in equations like E = mc squared. So kind of cleverly, we named, we're using velocity here to present solar light through basically a velocity template. So Apache Velocity is a very fast, very lightweight, clean templating language. And so Solr has a response writer that runs it through that. All right, so we've got this instant user interface, but we need to do a few customizations as we go. So we're going to take some baby steps as we go to customize this application for the domain that we're in. And the domain, of course, is indexing these files. So what we're going to do is we're going to edit the schema. In Solr's configuration directory, there is a file called schema.xml. This schema that comes with LucidWorks also comes with Solr. It's the same schema. has several example fields in there. Actually working with a number of customers, you'd be surprised, actually you probably wouldn't be surprised how many customers actually leave all of these types of example fields in their schema. So my recommendation is clean up that schema right away. It's okay to start with the example schema, but simply remove the example fields from there, the ones that you're not going to use. And then, of course, customize and add in any new fields that you're going to do. At this point, we don't need to add any new fields, although in a later step that we're going to do today, we will add another field. The next thing that you can do with Solr's configuration is you can actually make the URLs that you request to Solr domain specific in a sense. So what we want to do is be able to have a nice clean set of URLs that our client application can request to Solr and have smart defaults or even some invariants where the requesting client can't even change particular parameters. So in this particular case, what we're going to do is remove some unused example request handlers. This is in the Solr config.xml file. And we're going to add some custom handlers throughout this presentation with some nice defaults. And then we're going to, if we change URLs and we're using this velocity response writer, those URLs are actually baked into the template, so you need to customize that template, the templates as well. And that's going to be a recurring theme throughout this presentation and your prototyping, is the templates there, and of course Solr's example schema are meant for a starting point, and you need to tinker, you need to fiddle with that from there to make your application domain specific for you. And the final point I want to make here is make a habit of tidying up after each step here. Robert Martin, one of my mentors, always talks about cleaning up the dishes every night. Don't leave dirty dishes overnight. So we want to do the same thing here. And after each step, we're going to tidy up the URLs. We're going to tidy up the user interface slightly, just so that we don't have any broken windows or any dirty dishes left for us in the morning. All right, so specifically, the changes that we're going to make for the schema, we're going to add a body field. Now, the reason we're adding a body field for this is we want to make the field stored. Okay? By default, when we just index that PDF file, we index into a text field, a field called literally text. And that text field in the schema is set to be unstored. Now, that's a perfectly reasonable thing to do. However, and you'll see the comment here on this slide down below that if the content goes into the text field, it is unstored, therefore we cannot do things like highlight it. Okay, so highlighting in Solr requires the field contents to be stored within Solr. So what we're going to do is create a new field called body, and we're going to then create a copy field configuration in the schema. And this copy field is going to map every incoming field into that text field. Okay, this is the text field that we're going to replace with the body field. However, we are going to still use that text field. No document coming in is going to be sending in the text field name, but we're going to, under the covers of Solr, map all of the content that comes in into that text field. This gives us basically a catch-all field that we can search without having to specify any field names. It just gives us a very easy way to search content that comes in. This may not be the final way that you have your configuration, but it's a good way to start to work with Solr. And then finally, in the Solr config XML, we're going to change the update extract handler. It's got a text field. We're actually going to replace the text field with the body field here. Okay. All right. The next thing we're going to do is clean up the URLs. Okay. We're going to get rid of that silly ITAS, the thing that makes Solr URL sound like a disease. It's not Solritis, it's Soleritas. But we're going to replace that URL. Okay. It's an ugly URL meant for you to change. And one of the things I like to change it to is browse. Okay. So in this particular configuration, we're going to make this domain specific in that the field list, the FL parameter that we're going to return, is specific to the content that we indexed. So we have an ID field, we have a content type, we also, the extract handler creates the content type, the last modified fields, and we do want the score back as well. This is the value that we've seen generates during the search to rank the results by relevancy. Okay? And we want a facet on the content type field. Okay, so we want to be able to facet on whether the document's PDF or Word or HTML, those types of things. And at the very top of this configuration that we have here, these are the defaults that we're setting for the velocity response writer. We're telling it to use the velocity response writer. We're telling it to use a template called browse. And that browse template gets wrapped with a layout so that it gets a header and a footer wrapped around it using the layout template. And the next line, the title line here, is not a parameter that Solr even cares about. It's simply a parameter that gets passed into the response so that our template can use that value. It's just really an example to show you that we can send parameters into the user interface that is generated and parameterize it this way from the configuration. All right, so after we change that configuration, we need to restart Solr. Actually, the next slide is going to tell us that we need to do that type of thing. But after we restart Solr, we now have the /browse URL. We've replaced the other one that we used earlier with /browse, and we have our own custom facets that get displayed. All right, so anytime you're changing Solr's configuration, be it the schema or the Solr config, or generally any types of things that are under that conf directory of Solr's, of the Solr home directory, you need to at least restart Solr to have that configuration picked up. I'm going to go through a couple other steps here that are strongly recommended. First of all, back up the original files. When you get LucidWorks for Solr, take that conf directory and just copy it to another directory so that you have that saved off for reference, or in case something gets messed up and you need to go back to one of the originals. Okay. You stop LucidWorks if it's running. You can either Control-C if it's running interactively, or you can run the stop command. And also, while we're prototyping, we're not really indexing that much content. We're just going to index 1, 2, 10 files, something like that, just to prove it out in this particular example here. We simply, while we have Solr stopped, we can remove the data directory. Okay, this is going to remove the entire index that was created, and some other things, maybe like the spell check index, if we've been using spell check. And always be able to re-index from scratch. This is a really important thing that you need to develop from the start as you start building your application. Have a script of some sort that you can run that will index your entire content into Solr in some fashion. Now, of course, at large scales, this becomes a much bigger issue, but in this particular case, for prototyping or for most applications out there, we can re-index our entire universe in a pretty short amount of time. And then after you stop, delete the index, and then you restart Solr, and then you run your re-index script, whatever that happens to be. Okay, next thing we want to be able to do is customize how the hits look. You saw in the default view where we had a generic field name : value, kind of in an arbitrary order. We'd like to make that look a little bit better. We want it to look like our boss wants it to look, where it's going to show the file name that we indexed, and then perhaps just the last modified. So there, underneath that conf directory in Solr is a velocity directory, and there's a hit .vm. VM stands for velocity macro, and you can customize this template or any other VM templates that are there to your liking to get the user interface how you like. Now, one of the nice things about the way this velocity stuff works is you do not have to restart Solr in this particular case to change the view. You simply change the template and hit refresh in your browser, and you will get the latest values, the latest templates. Let me just go through this template a little bit here. Within this hit VM template, this hit VM template is being called for each one of the result documents from another template. This is from the browse template. So if you look at browse.vm, you'll see where it has an iteration that goes over each one of the results returned from Solr, and then has a $doc object here that is then put into the current scope, so we can use this $doc object implicitly within this hit VM template. And from that $doc, and this $doc is simply a Solr document object in Java. And you could go to the Solr's Java docs and find out what methods there are on that. Here we know there's a get field value, and we want to get the ID. And we simply make that bold. And then we make a last modified view here, and we get the field value last modified. One interesting thing here is we use the $! Exclamation point for that particular one. If you use that exclamation point, what that does is it omits writing anything out to the UI if the value returned is null. If it is null and you do not have that exclamation point there, then you will get literally $doc. Whatever in the actual output. So this makes it nice here. However, and we're going to see this on the next slide, if we would like to not even show that text last modified, we can. If we don't want to show the last modified at all, we can simply use Velocity's if command here, and if there is a value for last modified, then we'll display it. Otherwise, there won't be anything shown there at all. All right. We want to do a little bit more customization here. We want to make each one of those file names, or the IDs within Solr, we want to make those hyperlinks. And we can do that by simply wrapping an anchor tag around the ID, and we're going to use the URL scheme file : //. Now this is pointing obviously to your local file system, and you are running Solr through a server, even though that server is running locally as well. So unless you've configured your browser to make that possible to click from one domain into your local file system, your browser most likely is not going to allow you just to click on that. However, you can right-click on that and then open that in a new window, and Solr and your browser will display that file for you. Okay, so that can be handy. And of course, if we were indexing crawling web pages, we could simply use the URL of the web page there. Okay, next up, we want to add highlighting. So what we're doing is just incrementally adding niceties to our user interface and to Solr's capabilities here, because we know in our end result that we're going to want highlighting. So within that browse handler in Solr config.xml, we add a section on highlighting. We turn highlighting on. We tell it we want to highlight that body field. Remember, this is the body field that we changed earlier so that the extract request handler is indexing the content into that field. And then we want 3 snippets back, a maximum of 3 snippets. These are the fragments that come back from the highlighter. The default is 1, but we want 3 to give a little bit more context there. And here's the end result at the bottom. The word search right here. I searched for the word search, and it is italicized in the output, and we're fragmenting that. And then up above, we see the template where we simply added within the hit VM template for each fragment in, and we have this kind of ugly expression here that is navigating Solr's response structure. And it is a little awkward. You see response there, but we then navigate into the highlighting section, and then we get the section, the highlighting section that's specific to the field for the ID, for that particular ID, for that particular document that we're looking at, and then we get the body piece of that response. And then we just iterate through all of those fragments that we're getting back and just put dots around it and output the fragment. Okay, so that's why we see the dots in the output here. Next. All right, so the next feature that we want to add to our application, to our prototype here, is spell checking. The spell checking gets a little tricky here. There's a lot of changes that are needed to affect this. We need to add a field type to Solr's schema. We're going to add a text spell. We need to add a particular field called spell. And then we're going to copy field any of the fields that we want to, any fields that are going to have suggestions in it, the terms that we want to suggest. We're going to copy that into the spell field. And then we actually need to change Solr's Solr config XML to enable the spell checker properly. So we need to change the field name to spell that's in the Solr config XML. We need to set the spell checker to build on commit. What this will do is anytime you add content to Solr and then you issue a commit, it will rebuild the spell check index from scratch. And then for our particular request handler, for that browse request handler that we're using, we are going to add the spell check component to it. And of course, as we've changed all of this configuration, we need to stop, delete the data directory, restart, reindex, and then we're going to tweak our user interface so that we get the spelling suggestions added to it. And all of those things that we just mentioned actually aren't all of that complicated here. We have a text spell field here, and the text spell field is specifically analyzed slightly differently than our normal search fields. We want to do very light analysis on it. We still want to break it into words, but we don't want to do things like stemming or injecting synonyms, that type of thing. What we want to do is simply tokenize it and lowercase the terms. And then those will be the words that will get suggested to the user. And then the next section is where we added the field name. We added the field spell. It is of type text spell. And then we added the copy field. We're simply going to copy the body text into the spell check field. And then in our Solr configuration, we change the spell check configuration that's in the example to use the spell field rather than the name field. And we set the build on commit to true, like we mentioned earlier. And then this bottom section here is within the browse request handler mapping, and we turn spell checking on. We want to collate. This means take the entire query that the user issued, give us suggestions back for each one of the terms within that query, but then also glue all of those terms back together and give us a single string that is the best suggestion for all of the terms that they typed in. And then finally, we add the spell check component to that browse request handler as well. And then this is what you get in the user interface. If you add that little template segment that's shown, you get you'll get the results that you see there in the display. And that little section there simply navigates Solr's response data structure to get back to that collated suggestion field. All right, so we're going to add a little bit of pizzazz to our application here, just to show you that it's pretty easy to do some of these splashier things. We're going to add a pie chart. It's not a particularly pretty one, but it actually it was very simple to integrate, and it's quite easy to integrate other types of these componentry into the UI. Okay? In this particular case, instead of showing the actual facets, we're going to, as the file type and the count, we're going to generate a pie chart that represents that facet data. Okay? Now, how did I get this JavaScript stuff to work in there? I did not have any pre-canned JavaScript pie chart knowledge. I just Googled for JavaScript pie chart, and I came across this JS charts. I looked at an example. It looks easy enough to integrate, so I downloaded it. I placed the jschart.js file, so one single JavaScript file. I placed that within the root directory. I created a script subdirectory within the Jetty. I'm using Jetty in this particular case, not Tomcat, and I placed that JavaScript library there. This is one of those things that LucidWorks adds. It adds this root context, as mentioned before. This allows us to serve some static things like images or JavaScript libraries. And then once I put that chart there, that library into the root context, then I just integrated that into our user interface. And this particular slide here might be a little ugly in that there's a lot shown here, but literally this is everything that it took to get these charts generated. And actually, it's even parameterized a little cleverly here so that we can generate pie charts or bar charts here. Okay, so within the layout VM, which is the wrapper that goes around the results that we're showing, we add in the JavaScript library so that it's at in the head section of the HTML response. And then I created a new template. I called it jschart.vm. In here, I'm grabbing some parameters from the request. So I'm grabbing the facet field parameter. So I could literally generate a pie chart off any particular facet field. In this particular example, we're only dealing with the content type as a facet, but it's actually parameterized here for any facet field. And then I made up my own parameter here called jschart.type, and this can either be pie or bar, and it will change what gets generated there. And then I get at all the facet data, and I write out a bit of JavaScript into the response, the HTML response that comes back. And this is where I looked at the JS chart example and simply followed that and customized it slightly for the particular velocity stuff that we're doing here. I want to iterate over each one of the facets. I'm going to add each one of the facet value keys and the values into an array that the JS chart library uses. I set the title to be the facet field value, and then I draw that, and it gets drawn into this particular div that's right here at the top before the script. And at the bottom here, you see the URL that's used to generate that pie chart. Okay, so this is actually quite a long URL, and we can do better than that by doing what I mentioned earlier, where we clean up after ourselves here. In this particular example here, unfortunately the text here got a little mangled in translation, but this is a request handler in solrconfig.xml, and we're defaulting to the velocity template JS chart, and we have a default JS chart type of pie. We have rows. We don't need any rows back. We're simply showing the facet value, so we don't need any search results back, and we're going to facet on content type in this particular case. Okay, so what we did was simply take that long URL that we just did and simplified those parameters and defaulted them in Solr config. And here's the example. We can make standalone views of each one of these types here by making a request to Solr JS chart, and JS chart type equals pie or JS chart type equals bar. And we are wrapping it with the layout. This layout gives us a standalone HTML response. Rather than just a fragment that jschart.vm generates, we wrap that with the layout so that we get a full-fledged HTML response. Now, we may want to embed that particular chart within the full user interface. And so what I did, and I'm not an HTML designer here, I just did a few little quick things here in the browse VM template. And within the facet field loop that you'll find inside of that browse.vm, I'm calling out to the JS chart library. Well, I make a hyperlink that has some JavaScript that will get executed when you click on that hyperlink. And when you click on that hyperlink, what it does is it calls to that JS chart without a layout and pulls in just that particular fragment of response from that template and displays that within a particular div. And at the bottom of the code here, you'll see a div that says JS chart by field name. And so we can either click the pie or the bar, and what gets written into that particular section there will toggle between the two, and we'll get those charts just generated right there inline in the user interface. Now, the reason that we're able to do this particular trick here by default is that we're using the jQuery library. The jQuery library actually comes with Solr. It's built into Solr because Solr's schema browser in the admin section has fancy Ajax-y things going on in there. So we're simply leveraging the jQuery library that comes with Solr itself so that we're able to do these Ajax-y things very, very easily here. All right, so that's basically all of the types of features that we wanted to add into the user interface. But we also want to be able to, as we're developing our application, we're going to want to troubleshoot some things. We're going to want to see why particular documents scored the way they scored. We might want to do some relevancy tuning. In fact, that's a very common thing to do with your application. Once you get it up to scale, you're going to want to play around with how the results are ordered. And thankfully, this Solaritas, the Velocity Response Writer, has some debugging capabilities in there. So if you use Solr's debug query parameter equals true, the user interface will adjust slightly and allow you to see the scoring explanations for each one of the hits. And it gives you a little bit of JavaScript hide and show for those explanations, so it doesn't clutter up the results. And it also, in a slightly more ugly fashion, it dumps the request and response objects, the two string versions of those, at the bottom of the page. They're obviously going to be kind of big and kind of ugly, but it is useful to kind of navigate that if you want to see what's coming across in the response. And here's what it looks like when we add debug query equals true. We search for the two terms user interfaces, and we got our results. We got the hyperlink there. We've got the fragments with the highlighting. And then because we added debug query equals true, we get this toggle explain. When you click that toggle explain, it will show textually why that score scored the way it did. Okay, and of course this is Greek to most of us. But if you look at the math here, you can see why the stuff scored the way it did. And when you have a need to tinker with this stuff, you will start to understand where these particular things come from in terms of the IDF, the inverse document frequency, the term frequencies, query weights, and field normalization factors. All of the types of things that Lucene uses in the scoring is shown right here for each one of the hits. Okay, now what? We've got this user interface, we've got our faceting, we've got our highlighting, we've got the spell checking in there, we've got the debugging. Now what? Well, you're probably going to want to show this to a decision maker so that you can press forward with deploying Solr within your environment. Maybe you want to customize the header and footer, put your own color schemes from your company in there, put your logo at the top corner there, just kind of make it a little nicer there, show your boss, and then ask him what now, okay? Because you are now ready to go to the next step. We've done a quick prototype, and we obviously have not tied this to the proprietary enterprise backend, but we've gotten content in there. Now we know we can get that content into Solr if only we can get that content out of this big, complicated backend system. Okay, so that's probably one of your next steps if that's your particular use case. A few other general next steps. Create a script that will do full indexing. Okay, you're going to want to rerun that thing. Anytime you tinker with Solr schema, if you're going to be doing a lot of relevancy tuning for a while, or adjusting how analysis happens so that you can change stemming and lowercasing and different language analysis, those types of things, you're going to want to be able to re-index your content very easily. So start that process right away. Get some kind of scripting going on so that you can index your content either full, also incrementally if you have a way to know what's changed since the last time you ran your indexer. Now, Solr does include some capabilities for indexing content. You can index, as we've seen, we can index files that way, but you're going to need some script that's going to pass each file in that way, or you can index CSV data, or you can use Solr's more sophisticated data import handler where you can bring in database content, crawl feeds, or index XML, those types of things. So there are some indexing capabilities built into Solr. You just want to be able to script that from your environment. You're going to adjust your schema. You're going to be tinkering with fields types, the analysis process. So there's definitely some work to be done there in your application. And as needed, there's a lot of configuration within that Solr config XML that's going to tune the caching capabilities of Solr, the indexing parameters, the low-level leucine indexing parameters. These types of things may or may not be something that you need to mess with. Certainly don't mess with them until you need to, but often you run into issues at scale where you do want to control the caching. You do need to adjust the indexing parameters for batch indexing type capabilities there. And then begin the process of figuring out what it takes to deploy this thing into your staging production environments so that you get that smooth process going from the development prototype that you did and start that process into production. Is it done? No, it's not done. We just built a prototype, okay? We just hacked a few little templates. And yeah, it may look nice, but I would say keep it a bit ugly for now, because if you show a very slick user interface to your boss, which, you know, arguably this is, it's an okay interface. It's you know, it's useful from the start, but it's not done. This is you know, velocity templating coming from Solr itself. So be careful with overselling that prototype. It's literally just a prototype at this point, and you are going to be integrating this into your larger website or intranet or wherever you need to place this, and you're likely going to be integrating it into a different type of programming environment, so maybe a PHP or a .NET type of environment there, where the velocity templating is not quite what you need on your particular front end. So, but this prototyping does prove out certain things. You've now created the request handlers. You've created some clean API basically from the client to Solr, and you have implemented the capabilities of highlighting, spell checking, and fasting, those types of things. So you do have the basic infrastructure in place already, and those requests that are being made to Solr are the same requests that are going to be made from your client system into Solr. So you can simply copy and paste things from the Solr logs, those types of requests, and use bits and pieces of that template maybe if you want to get going into your application. There's a few other interesting prototyping tools that are out there. First, not quite a prototyping tool, but a very, very smooth way to get content into Solr is being able to use the CSV update handler for column or comma separated data. It doesn't have to be comma separated. Tabs work quite well as well. But you can index this columnar data into Solr very easily. It's a very, very fast way to get even a large amount of content into Solr. Of course, in this particular case where we're indexing files, that's not quite applicable here. But if you are indexing, say you've got a database, and again, Solr includes the capability to index databases, but it is a bit more hairy of a configuration. You're going to have to go read some documentation and tinker around to get that to work. But because we have this CSV update handler in Solr, you can take a disconnected stance here with your prototype, in that you can export data from your database or from some other content store and get that into CSV data. So it's very easy to do a SQL select and then output that as CSV, get that as a file system file, and then upload that into Solr. So you're not literally tying the two together, but you can get the data from one to the other to prove things out. And then you could optimize that process if needed over time so that you're using Solr's data import handler and benefiting from that type of connected indexing. So again, CSV, just a very nice way to get content in. Solr's administrative interface has what's called the schema browser. This is a nice way to look at what you've indexed and the field structures and the analysis and kind of the number of unique values in particular fields. So if you're doing kind of exploratory stuff where you're taking maybe a CSV file of all kinds of data, you may not know exactly what the profile of the data is like, what's a good facet, what can I do with this particular data set. The schema browser is a good way to navigate that and find out how many unique values there are in a field. If there's a small number of unique values, you are, that could be a good candidate for faceting. Of course, we talked about Solaritas, we demonstrated there. There's a few other interesting things that are out there. There's the Solr Explorer, which is currently a contribution to Solr, has not been committed to Solr, but you can download that from this particular JIRA issue. And what it is the GWT, the Google Web Toolkit user interface that ties to Solr and allows you to pick and choose fields that you want to facet on and sort on and all that sort of thing. So it's basically a developer-like tool to navigate Solr from a nice user interface. And the last thing I'll mention, and this is just kind of a pet project of mine, Solr Flare. It's a Ruby on Rails plugin. Very easily you can point it at a Solr installation and have it give you a faceted view. It's got a couple of nice bells and whistles built into it above and beyond what we've already seen. It's got Ajax Suggest. It's got pie charts for each one of the facets. It's got invertible filter queries so that you can say, show me everything within this particular facet value, or show me everything that's not within that particular facet value. It's got like a browser session-based saved search capability in there, so that you can play around there, and it actually takes your saved searches and makes them into facet queries. So a few little nifty things in there for prototyping or just kind of exploring a Solr index. And finally, just some words of wisdom here about what you want to start doing. You've now got Solr up and running. You've got your content being indexed into it. You're going to want to take some additional steps here. You want to get some baselines for your performance, your scalability, and your relevance. You're going to want to start pushing this thing to scale and see if Solr is going to handle it. Do you need additional servers? Do you need to go to distributed search? Do you need to use replication? These are types of questions that you're going to need to answer as you go into production. And is the relevancy good enough? Okay, what kind of tinkering do you need to do with that? Lucene and Solr give you an enormous amount of flexibility in terms of this relevancy. So you want to go ahead and start getting a handle on those types of things, and these are the types of things that you're going to think about and have to address as you move from this prototypical stage into staging and production environments.